We are reaching the end, and it has to happen sometime, and the time is now. We have one announcement left that makes any sense to announce. That is at 5 o'clock we'll have lightning talks here, and that's it. So we're going to learn something about Enigma and the bomb.
Hi, everybody. Sorry for the delay. Apparently, bringing 3 different machines here isn't enough to connect. So, luckily, one of the guys over there helped us out with the 7-box that actually was able to do dual display, or at least mimic the display. So, on with the discussion, or the talk. This is called American Bombe, How the U.S. Shattered the Enigma Code. The first thing to understand, well, few disclaimers, actually. First, I am not a historian. I have an interest in this stuff. If I make a few mistakes on the dates, I hope nobody, kills me for it. Aside from that, the International Spy Museum rocks. I don't know if anybody here has been to it. It is one of the museum itself is pretty interesting. If you don't want to go to the museum, go to the bookstore. The bookstore is one of the most amazing places I've ever visited. I got so many amazing books there, and it's not even that big. So if you're in DC, if you have a chance, the International Spy Museum is an amazing, amazing place. So, like I said at the beginning, it's American Bombe. That's bomb, not bomba. Most people say bomba. It can be a little bit confusing. It's actually one of the people who worked in the U.S. on the U.S. naval enigmas. In his writings, he wrote B-O-M-B because he had never seen it written out before. He was always referring to it just in talks with people. So when he wrote it out for the first time, he wrote B-O-M-B. The other thing to keep in mind is that enigmas and the methods that the British and the U.S. naval, the cracking that they did, they were electromechanical attacks, not electronic. The Enigma machine was, of course, electromechanical, and that is an important distinction because we're kind of at the dawn of the electronic age, where a lot of stuff is a mixture of electromechanical and electronic. Electromechanical, obviously, you have electrical current running through, but you also have gears rotating in order to move things forward. It's not purely electronic. So some terms related to what we're discussing. We have Enigma, which is obviously the actual machine that's doing the encryption and the decryption. Actually, the machine was used for both. Not everybody knows that. Ultra, which is the name of the program. That's what the British referred to the program. That was their efforts to crack Enigma, and later what the Americans also would refer to the program as. And Shark, which is, or Triton, which is specifically the naval cipher that the Germans introduced. Triton was the name that the Germans gave it, and Shark is what the British and then the Americans referred to it as. So that's a lot of zeros. That's actually 10 to the 145th, and that is the number of different possible combinations an Enigma machine could encipher a piece of text to. This is just to give you a little bit of an idea, in general, what kind of a challenge they were facing when they were dealing with Enigma. A little bit more history of the Enigma. Enigma, the first model, was introduced in 1923. The Polish were the first to actually get their hands on one and figure out how it worked. And eventually, about 5 weeks before the war started, they handed over all of their information to the British and the French. Interestingly, also, the name bomb comes from the Polish cryptographers who were working on their own code-breaking things. I think that they were first to crack Enigma, the earlier versions of Enigma. The machines that they were building to automate the process of cracking it, it's a little bit of a dispute depending on who you ask. Some people say it's the sound, a ticking sound, that the machine made, and that is why they called it a bomb. Other people say that it's just candy or an ice cream that the Polish cryptographers liked. It's, certainly like they were saying in the last talk, nothing changes. People give weird names to stuff. This is the original patent. This one's marked 1928. From what I've been able to see, the first inklings of the Enigma machine actually is in, I believe it's 1913. But this is the actual patent that was on file, And yeah, so that's the Enigma. So how the Enigma machine works. I'm assuming most of you guys know how it works, but just a little bit of background. This is a 3-rotor Enigma, not a 4-rotor Enigma, which we'll discuss a little bit later. But the 3-rotor Enigma, you can see at the top, you have those 3 little dials with stuff protruding. And directly underneath it, you have the light board. The light board is where the enciphered text or the deciphered text would appear. And directly beneath that, you have the keyboard, where you would actually type in the text. And at the bottom, you have the stecker board or plug board. This is a box of rotors. This is a box of 7 rotors. Later on in the war, they would eventually have a choice of 8 different rotors that you could possibly put in a machine. It made it much more difficult to crack because any one of these rotors could be in the 3-rotor Enigma, any of the 3 positions, which meant that you had 336 possible combinations. 9 times 8 times 7, 8 times 7 times 6, so it should be 336 possible wheel positions that you start with on top of the rest of the stuff. Here's a little bit of a kind of a cutaway. You can see the way that the individual rotors worked is there are contacts on the side. The contacts would encipher each letter to another position. So on one rotor, C would go to X, and well, not to X, but C would go to V, and on the next rotor, it would go, from V to Q, and it would keep going and keep going. And so that's the way the rotors work. Then you have the plug board. The plug board actually wasn't in the earliest models of the Enigma. I forget exactly when it was introduced, but the plug board added another level of complexity because you could route, in this case, A is routed to O and S is routed to J. But that, in the end, actually caused some problems, not for the British or the Americans, but caused some problems for the Germans because while A is steckered to O, O was also steckered to A, which reduces the number of possible permutations. So the British got this information from Poland, and once the war was started, they had been working hard and had actually been able to crack Enigma. But as the war went on and as the U.S. was drawn into the war, they realized that they were not going to be in this alone. There needed to be cooperation. Specifically, in 1941, in the summer of 41, there was a meeting between kind of the head of code breaking on both sides of the Atlantic. Agnes Driscoll was one of the top U.S. Navy code breakers. She was leading the U.S. efforts to crack Enigma. Driscoll relied mostly on old school methods. She believed that intuition would be the solution to most things. She relied heavily on generating just great volumes where people could look up all of the possible solutions, and that was really going to be the efficient way to do things. She did not believe in electromechanical automation. She just didn't think it was the way to do things. On the other hand, Alastair Denniston was the head of Bletchley Park. Obviously, Bletchley Park, Hut 8, Turing, that's where electromechanical and eventually electronic code breaking really got its start. He thought that rather than relying on code breakers who were specifically geared towards intuition or things like that, he believed in focusing on mathematicians, young up-and-comers like Turing, and they would help automate the process and reduce the time necessary to crack all these codes. So Agnes Driscoll was working at OP-20G. OP-20G, it's a simple acronym. It stands for the Office of Chief of Naval Operations, 20th Division of the Office of Naval Communications, G Section. Real simple. OP-20G was the U.S. Navy's cryptanalysis group during World War II. That is where everything was going forward, but having Agnes Driscoll at the head really, it got them to a point where they were just hitting a wall. And already, they had the meeting with Alastair Denniston where in the summer of 41, and Alastair Denniston was offering the U.S. a lot of information about the British code-breaking effort, specifically the British bombs that were under construction. But Agnes Driscoll didn't want anything to do with it, so she flat out refused the offer. So, but by the fall of 1941, it was clear that, she was hitting a wall, she wasn't getting anywhere. Her assumptions about the way the Enigma worked were just, they weren't right. She was sending requests to the British for more information on the way the Enigma worked, and she was getting a little bit, but really wasn't getting anywhere. So in November, she actually was open to the idea of having a meeting with 3 MIT students. OP20G was, kind of coming into their own and realizing that this wasn't going to work. They needed to approach their own code-breaking efforts in terms of electromechanical or electronic code-breaking. At that November 3rd meeting, the MIT students met with Driscoll, found out what was going on, started going around to some of the other code-breakers, and they started asking them the simple question of, what can we do to automate your process? Interestingly, the MIT students, those 3, became some of the head codebreakers at the M section of OP20G, and remained there throughout the war. So the reason that Denniston had been so willing to share secrets with the Americans when he came in the summer of '41 was because the British were concerned that eventually that the Americans would come to the realization that they needed to conduct their operations differently, and they would start their code-breaking program of their own, the electromechanical electronic code-breaking program of their own, and build their own bombs. And England did not want them doing that. They really were concerned that the Americans would talk. I guess I was naive. I didn't know that that was a stereotype of Americans, especially during that time. The more I look at propaganda posters, which, by the way, are amazing. The artwork on propaganda posters you can find online is just awesome. There's plenty of propaganda about keeping your mouth shut. And it was a real concern for the British, and that's why they were willing to give some information. They felt that if they clued the Americans into what they were doing, the Americans wouldn't try to start their own program. They would say, okay, you guys got it covered. Whatever we pick up on our boats, we'll send to you. Whatever you get, you'll send it to us. Everything will be fine. Everything will be peachy keen. Obviously, once America really started getting into the war, that wasn't going to be an option. But for some reason, they felt like that was the best approach. And ironically, after the war, the information that was leaked about what was going on in terms of code-breaking of Enigma, the Americans weren't the ones who leaked anything. It was the British. All the information that you can find on the American code-breaking efforts specifically related to Enigma, it was all declassified after 2001. So there's really not that much out there. But there was a book published in the 70s called The Ultra Secret, and it was actually a Brit who was the one who broke the silence first. So I guess they get an A for effort, but an F for carry through. So moving on, once OP20G had decided that they were going to move forward with their own bomb program of their own, they needed a place to design and build these. That place was NCR, the National Cash Register Company. Has anybody here heard of NCR? Okay, some people know of NCR. NCR, not exactly the first place you would think of. Most people would say, oh, it's early computing days, IBM. NCR, it was actually founded well before IBM, founded in 1884. They really were an industry leader and were top of the line at that time. By 1906, they already had a cash register that was powered by an electric motor. And they employed Thomas J. Watson, who after a dispute left and went on to really form IBM and form the culture at IBM specifically.
Tabulating machines.
I'm sorry?
Tabulating machines company. It was called.
Right. At the time when he joined them, it was called the Tabulating Machines Company, but he was one of the ones responsible for changing the name to IBM. NCR was a major player. They're still around today. You can find their ATMs all over the place. You can find cash registers sometimes. At NCR during that time, the U.S. Naval Computing Machine Laboratory was established. The U.S. Naval Computing Machine Laboratory was, I guess, the equivalent to Bletchley Park in America. And that is where, unlike I think, in Bletchley Park, I think it was mostly focused on the ideas and not so much the building of the machine. but at the U.S. Naval Computing Machine Laboratory and NCR, that is where they both designed and built the machines. And National Cash Register Company was located in Dayton, Ohio, and so that is where all this stuff took place. So the man who worked for NCR and was chosen to head up this project was Joseph Desch. Joseph Desch, he was an employee of NCR, and he was brought in mostly because they initially started with the people from the M section, people like the 3 MIT students that they had brought in to first talk with people like Agnes Driscoll. They were focused on developing the process, but they were not able to actually produce machines. Their designs were not able to be implemented in a timely fashion. So when they needed someone who had a history of actually designing and building machines, they went to Joseph Desch. He was a pioneer in designing fast pulsing miniature tubes used for counting and tracking. He had actually beaten MIT to the creation of a fully electronic digital calculator in 1940. It was, I believe, the size of a room, but it was the first electronic digital calculator, and he was the first one to get there. So they felt that the guys in the M section would design it, and he would be responsible for kind of correcting designs, refining them, and actually getting it built. So the way that England at the time had been carrying out their code-breaking efforts relied heavily on 3 things. The 3 things were the actual Enigma rotors, code books, and cribs. Enigma wheels, obviously, pretty obvious. Code books, also pretty simple. Both of those were captured from U-boats, usually, sometimes in the pockets of Enigma operators. I believe the first 2 Enigma rotors that were captured, the guy had thrown the Enigma machine overboard, but he had forgotten that he had 2 rotors in his pocket. So when they captured him, they got the rotors from that. And code books were also pretty hard to come by. They were supposed to dispose of them, and they were actually weighted with lead so that they would sink to the bottom of the ocean. When they, as soon as they threw them over. Cribs, a little bit different, obviously not an actual crib. They were derived from common German phrases, previously decrypted messages, or just lazy Enigma operators. You had people, ending things in a certain way with a particular sign-off, that you could use that as a crib to test against. If you had all sorts of stuff like that, just lazy people or people who didn't understand, what was going on there. The Americans wanted to move away from a reliance exclusively on these things, and they wanted to produce just a full brute force attack and create a machine that could do that. They wanted their machines to really take a quantum leap forward from where the British had been. They initially wanted their machines to be fully electronic, not electromechanical. That's probably a large reason why they chose Desch, because he had his successes with electromechanical, but more successes with electronic machines. And they also wanted their machines to be able to tackle both the 4-rotor Enigma codes and the 3-rotor Enigma codes, something that the British machines were not able to do. England actually started constructing 4-rotor Enigmas. They were never really reliable, and I think they never fully got them into a full production run because of the American efforts. So, free labor to win. Well, what does that mean? Joseph Desch worked on 13 other projects. It became pretty obvious this was going to be the most difficult one. There was a budget of about $2 million for this project, but what the U.S. Navy was asking for was well over 100 times faster than anything that had been previously created. The British were producing machines that were able to crack Enigma, but because they weren't that fast, that's why they had to rely on the things I spoke about earlier. He realized pretty quickly, though, that in order to construct a machine, at least with the design that he was trying for, and to make it fully electronic, they would need almost 20,000 tubes in order to get it to work. And 20,000 tubes, they had no power supplies that could supply enough power for that. The heat would make them completely unreliable. There was just no way to get that to work. So they were pretty much up the creek at that point. But the people, the superiors to Jesh at OP20G weren't happy, but they knew that he wasn't exaggerating, so they said, okay, that doesn't work, give us a solution. It's also at that point that they kind of realized, well, if you can't just construct it based on what's out there now, we're going to have to give you more information. Up until that point, Desch was just going to build it. So they said, we need a machine that does X. At that point, he was actually drawn into to the inner circle, I guess, and they gave him much more information on how actually the Enigma works and the full code-breaking efforts. He wasn't really, up until that point, fully in there. Desch, after he was brought in, he came up with a solution to make an electromechanical bomb, and I just like the art. I'm sorry. It's surprising. There's a lot of great art, but there's also a surprising amount of really racist art. So you got to be careful what you pick sometimes with this stuff. Desch's approach that was electromechanical wasn't purely electromechanical. What he was proposing to do was kind of a merge of the commutator wheels that were used on the British bombs to simulate individual Enigma rotors, and take his advances in high-speed electronics and the tubes to record and play back that information. They specifically would track the hits that the bomb would make and then rewind to the point. And that sped up operations considerably, because previously with the British bombs, it just kind of went past it, and you had to, there was a cold point test where you had to kind of realize where it had not made the connection and then go back and set it back to that point to keep going and try for another possible solution. So again, this was not going to be any small engineering feat, but it was very necessary in order to approach even close to the speeds that the U.S. Navy was asking for. Despite the fact that he was able to get, at least he thought at the time, he was able to get close to what they were initially asking for, he estimated that they were going to need 336 bombs in order to reliably crack Enigma. In order to crack, the three-wheel. They were going to need 336 because they were going to use one machine to check each possible rotor configuration. It's an insane amount. At that point, actually, the revised estimate of the amount it was going to cost was about $4 million. So they, within the course of a few months, they had jumped, from $2 to $4 million. Still, I guess the U.S. was desperate because they said, whatever, we're all in, just go for it. Every day that they weren't able to effectively read German communications, more boats were being lost, and every time they would sink a German boat, the Germans would build them faster than they could sink them, so they were kind of in a lot of trouble. So, Desch himself, though, while he was brought into the inner circle, he wasn't allowed to use the words bomb, Enigma, or naval computing machine laboratory with any of the people he was working with, and he was under extra scrutiny himself. That guy up on the screen, Bruce Meter, he was living in Desch's house. Desch had like a two-room hut or something that he built in Dayton, and Bruce Meter was actually living in the house with him. The reason for that was, although he'd gone through all of his clearances and everything else, apparently his mother had immigrated from Germany to England, and then from England to America at the age of 13. So they figured he might still have a connection, and because of that, cannot be trusted. Even though they were trusting him with things, at the same time cannot be trusted. And on top of that fact, it turned out that Desch had a second cousin who also lived in Dayton at the time, and their father actually was still in Germany. So there was somewhat of a connection, I guess a little bit more reasonable why they had their concerns. But they were not taking any chances with them. One of the interesting things is that the relationship between Meter and Desch was always strained, and Meter, since he was living in his house, was the one who OP20G called on specifically to give pressure to Desch. And he was there day and night, being, just putting pressure on him. And it's read in the books that, the guilt trips he laid on Daesh were just, eventually they broke Daesh, possibly due to his devout Catholic upbringing, with all the guilt that they were giving him. Not my words, that's actually, I believe, in one of these books. Despite the constant pressure, or maybe specifically because of it, progress was initially rather slow. It was clear that although they had initially set a delivery date of the early months in 1943, that was not going to be met. It just was not a realistic time. So, in December of 42, a man came to town. That's Alan Turing. And I defy anybody to find a picture of Alan Turing other than that where he's smiling. I mean, the car's obviously fake, but whatever. Mr. Turing comes to Dayton. So, in December 42, Turing actually, he arrived, I believe, in Washington, D.C., for a visit to see what was going on here and to possibly help out. And there's not so much information because the fact that one of England's top codebreakers was visiting America was a closely guarded secret. Not that many records of everything that was going on. And it's also, from what I've read, possibly he wouldn't have even come if the four-rotor Enigmas, four-rotor bombs that England was constructing at the time had been close to completion. It was specifically because they were not so close to completion. They wanted to see what America was up to. Maybe these crazy Yankees actually have come up with something. It was becoming clear to both sides that Daesh and his team were going to have the greatest chance of success. Turing actually sent a memo back after he spent some time at NCR and also apparently slept on Daesh's floor in his small two-cabin hut because in Dayton, Ohio, apparently if you were lucky, you got a spot on the floor in the hallway of the hotel, and if you were really lucky, you got a spot on the floor in someone's house. In Turing's memo, it's a bit of a mixed bag. He clearly has respect for Daesh and what he's doing. He's impressed with a lot of the engineering work, especially given the fact that Daesh wasn't given a lot of the information about what was going on in England. Bletchley Park was doing their stuff. Denniston came over and offered the stuff to Driscoll. When Driscoll refused, they didn't have the stuff, and then by the time Driscoll was maybe open, or the other people at OP20G were open to getting this information, Denniston was gone. He had been promoted out of where he was, and so they didn't have as much access to the information. So they were coming up with a lot of this stuff on their own and just getting kind of basic ideas of the way the Enigma worked. Turing was impressed with how far they'd been able to come without all of the previous work that people had done in England. But he also warned about some assumptions that Daesh had made that Turing had seen personally were not necessarily true. Daesh was planning on using commutator wheels, like the British, and he was going to use wire brushes to maintain contact with each of the 26 points on each of the commutator wheels. Turing had experienced that after they had tested it in the lab in England. When they finally produced the bombs, what happened is, as the wired brushes would come into contact with one contact point, it would kind of send it up into the air a bit, and they would sometimes bounce. They'd get brush bounce, is what they called it, and it'd bounce over the next contact, and they'd miss a possible connection or create a false connection somewhere. He also had reservations specifically about Daesh's use of different-sized commutator wheels in his first prototypes, and he strongly urged him to move to one single type of wheels. Obviously, if you have one type of wheel that you're replacing, because the wheels would need to be switched out for different configurations, it's a lot easier to manage over the course of time. So the first models, the first prototypes that came off the line were Adam and Eve. Adam and Eve, they were completed in February of 1943, and they actually did work. But they were prone to all sorts of oil leaks and would break down after just a few minutes of operation. Despite this, because they actually had working prototypes, or because they were absolutely desperate, the Navy pressed on with the project and was still asking for the full order of 336 bombs. They felt that, even if these machines were going to be fast enough so that they weren't going to need the full 336 bombs, and they ended up only needing about a third of that amount, they might, if the Germans decided to change Enigma code, try to update Shark or to change it a bit, they would need to test all the possible combinations, and so it would just, they needed the full order. So while they were constructing Adam and Eve, and as they were constructing the later models as well, an interesting problem came up. The problem was the number 26 was everywhere. The number 26, obviously 26 letters, so when you're dealing with stuff where you're encrypting and decrypting letters, if you're sending anything out to manufacturers, because although it was supposed to be constructed all in Dayton, there were some things that they just didn't have the capacity to do. They had to send out some of the parts, the wiring and other things to outside manufacturers. So they needed to hide the number 26. They did it a couple different ways. Some of the things were simple. When they would order wires, they want a different color for each one, so they'd order 28 wires instead of 26 wires in 26 different colors. They would also do things, one thing which wouldn't be so clever for this crowd, but in some other crowds it would work, they numbered everything from 00 to 25. 25, a little bit more of a round number, so, oh, okay, it's just, just turn it to whatever it is. Not something out of the ordinary. Yeah, they actually, sometimes the attempts to hide the number 26 or some of the other things that they would do to conceal exactly what they were doing would be to a fault. Secluding people in separate rooms in these buildings, led to people just, they're doing the one thing all day, every day for 2 years. Some of them, would go a little bit stir crazy from it. There's a joke, someone said that someone was sitting in a room and they're drilling a hole from one room to the other just to get power to the next room, and somebody said, oh, where's your badge? You're running wires here. Where's, I need your badge to just, looking through the little hole. They made every effort to disguise what they were doing, and they kept on pushing forward. And then finally, on May 28th, 1943, a technician by the name of Phil Bocciccio was running a test on Adam, the first of the two prototypes, obviously, and all of a sudden the machine stopped working. He had been working on this machine for quite a while, obviously, at this point, and he assumed it was just another one of the electrical shorts or something had gone on. But then, like magic, all of a sudden, the machine just, kind of buzzed back to life, and it started to rewind. And that was actually the first hit that they got, and the first time that they had used one of the American-built machines, one of the American-built bombs, to actually crack an Enigma cipher. After he verified, I think he ran it again and came up in the same point. He took it over to a technician in like another area, probably 3 blocks away or something, who was operating Eve, the other prototype. They ran it on it. Same thing happened. Sent it off to Washington and said, everything's, we got a success. Turned out at the time that the British had cracked it, I think a week or two earlier, that specific one. But the point was they were actually able to figure out what was going on, and they were being successful. Things were finally working. But things were not going as well as people would have hoped during the war. It was the summer of 1943. Things were starting to turn, but it wasn't set in stone that the Allied forces were going to win the war. Germans were still doing brutal damage to freighters all over the Atlantic in the shipping lanes. And it actually turned out that the Germans had been reading encrypted messages, specifically the ones encrypted with cipher number 3 from the British. About 2 years earlier, in 1941, the Americans had warned the British about the fact that the Germans were probably cracking their codes because the Germans seemed to have intelligence that could not have come from any other source. It's also interesting to note that England should have learned from Germany's mistakes because Germany specifically didn't make that many changes to the Enigma code because they were so confident that it was impossible to be cracked. They made changes and they had lots of different versions, but they had other ciphers and other options that they could have moved to had they thought that it was reliably being cracked, but they thought there was absolutely no way possible that the British were cracking it, and certainly if they were cracking it, it was not going to be with, any sort of reliability and any sort of regularity. So after that point, once they found out that the Germans were cracking cipher number 3, it seems pretty much since they started introducing it, so they probably had some advanced knowledge or someone on the inside who was giving them a lot of information. They switched over to cipher number 5, and once they switched over to cipher number 5, the German U-boats were never able to get above about a quarter of the sinkings that they had previously had earlier in the war. So at this point, the Adam and Eve were operating, and they were starting to gear up operations for producing the full run of American bombs. And Desch was kind of feeling good. Things are working. We're going to refine this process. Everything's going to work. But the U.S. Navy came back and said, well, you've had these small-scale successes. That's great. Now, since you got that to work, go to a fully electronic one. He was just pissed. He had been working. He'd said to them a million times, it's just not possible. It's also, he had to explain to them, I guess, that he wasn't opposed to electronics. He had built, his electronic calculator. He saw that this was the future. But when you're trying to produce something in the middle of a war, you're not looking for, the thing that's going to be the absolute best. You kind of need it to be the best that you can get right now. So, after some begging and pleading, and probably the thing that really turned it, he mentioned that it was going to put a strain on the, the resources that were, that they had very little of during the war, specifically the stuff that they would need for building all the tubes, and just the ridiculousness of, how hot it would get, and that while at optimal efficiency it would work as well as they wanted, it probably was not going to actually get there. They finally relented, and they let him continue with what he had previously tried to do, that merge of electromechanical and electronic bombs. And this is what the final U.S. bomb actually looked like. You could see on the front, you have the 32 commutator wheels. And this was just a massive piece of machinery. I think it was about 7 feet wide, and it was like, the bed of a truck, but, also like 6 or 7 feet high. It's just a massive, massive machine. And by late July already of 1943, 15 American bombs had been produced, but they were also plagued with some problems that had kind of mystified Desch. These were the final models, not the early production models. The bombs were plagued with false stops. It was kind of obvious that they were experiencing brush mounts, and they couldn't get them to work. They were afraid, obviously, at the time that their budget would be cut and everything will be for naught. So, late one night, Desch kind of was examining each and every little piece of the 15 operational bombs that they had, and he found that the surfaces of the commutator wheels were actually not perfectly smooth. They had intended for them to be perfectly smooth to help eliminate issues of brush bounce, but they weren't. So they gathered everybody they possibly could, stuck them in a room, gave them some sandpaper, and they sanded them down. It might not have actually been sandpaper. It might have been some steel wool or something. But the point is, they actually sanded them down. And that worked. That worked for a while. But after it had been working for a while, they ran into another problem. Now that they had sanded down the wheels, little slivers of copper that were created by the sanding were getting in between the points, different points on the commutator wheels, and were shorting out some contacts. So they introduced kind of just some ideas of getting everybody to clean all of the wheels all the time, and once they introduced that, they were able to get these operating efficiently and get them out the door. So they got them moving. By September of '43, the first shipments of bombs began to leave Dayton and make their way to Washington. They were located in Washington, D.C. for the remainder of the war. They were operated by the Waves, which were women who volunteered specifically, not specifically for this task, but female volunteers who were operating these things actually 24 hours a day, 7 days a week. By December of 43, not too long afterwards, decryption wasn't just the occasional thing. It wasn't that they were cracking it in 1 week. It wasn't that they were cracking it in a few days. By December 43, they were able to crack the codes within 18 hours. And that's really an important milestone because that meant that messages could be read on the same day that they were being sent. Once you knew what the settings were for the day, you got the later messages for the day, and you were able to actually read the messages and respond on that same day, sometimes even before the Germans were reading them themselves. But once again, I guess I'm going to hurry up a bit here. Once again, all was not perfect in the land of the bomb. They were being churned out at a rate of 6 a week and heading out to Washington, but there was a traitor in their midst, or at least they thought there was a traitor in their midst. One day, there was a particular technician at National Cash Register who was getting a ride home from a friend of his, another guy who worked there named James Montgomery Jr. He was a technician at NCR, had started working there a couple years beforehand, and he had given his keys to his car to this other guy to get in. He's like, oh, I'm going to go get my wife. I'll meet you at the car in a few minutes. Guy wanted to smoke a cigarette, started looking through the glove compartment for some matches or something, and out fell a bunch of letters from foreign embassies. And he said, well, this is mighty interesting. Brought it up to superiors at NCR, specifically, the group at NCR was working on the bombs. And what ended up actually happening with this guy is he was held for the remainder of the war. There's a whole thing that could go into this guy, James Martin Montgomery Jr. In and of himself. He was, I think the CIA started lying to the courts and prisons because they knew since he was a civilian, they couldn't prosecute him in a military tribunal or something, so they had to prosecute him in the courts, but they were telling him that the stuff was classified, but they were telling them, one day they'd tell him that it was radar equipment that he stole a piece of, next day they'd tell him that, he stole some tube from somewhere, and they kept on giving conflicting things, trying to give them a reason to imprison him and keep him in prison for the rest of the war while not revealing what they were actually doing. So, some numbers. There were a total of 120 American bombs that were produced and 220 British bombs. Americans, Daesh specifically, had designed his bomb to be flexible. And that was one of the great advantages of the American bomb. It was designed to tackle both the 3-rotor and the 4-rotor Enigma codes. With the flick of a single switch, they could switch it from 3 to 4-rotor mode. Again, the automation is really what made this way, way better than the British bombs. They were able to switch it back and forth, and the machines were so efficient that towards a later time during the war, they were able to go ahead and, during their downtime, start cracking the British, the 3-rotor codes that the British were responsible for cracking. So, they were really way more, way more impressive than you would think, given their successes earlier on in the war. And, so they produced a hell of a machine. That first guy, Phil Boccaccio, who first saw the thing, that was actually, I think they have it written down that's what he said. The machine stops, he thinks, oh crap, something's wrong. The machine rewinds, and he's like, wow, that's a hell of a machine. So I'm going to skip ahead a bit. So, keeping secrets. Like I said earlier, the British actually were the first to reveal secrets about the Ultra program, and Americans never did. Daesh himself never talked. Actually, his daughter, Debbie Anderson, who was born a few years after the war, she had no clue what was going on. She knew that her father had been working at National Cash Register Company. She knew that there was something to do with the war. She never had any clue. She found out actually almost accidentally years later when there was a display going on at some museum on the other side of the country from where she was, and it mentioned that that there were these code-breaking machines that were built at National Cash Register Company during the war. And she said, really? National Cash Register Company during the war? That's weird. My father was doing something then. Actually, after her father died, she found some papers on his desk that were from the Smithsonian, an interview that he did in the mid-'70s. There was some basic stuff on there saying, yeah, I was working on something, but the second he would talk about anything related to cryptography, it was all blacked out. So apparently, even the Smithsonian, well after this point, wasn't high up enough to get the basic information. She actually called up the NSA after she found those papers and said, "Hey, I've got this cool stuff, and would you like to see it?" And she showed up at the door and was led into some strange room where she was kept for several hours while people walked in silently, picked up papers, laughed, and said, "Wow," and then would walk out and come back with 5 other people who'd all go, "Wow," and then not say anything and come back. Luckily though, a lot of this stuff was declassified in 2001. So there are books. There's a fantastic book called The Secret in Building 26. This goes through almost everything related to what was happening in Dayton and a lot more. It's a great book. Bought it at the International Spy Museum. It's really the book that has the most. Most of the other books you'll find, they talk about what was going on in America at the time, but it's only a line or two. There's a lot of information that just wasn't available. So when they put out a later edition of the books, they included a little bit, but not that much. And last thing is, there's a lot of stuff that's still classified. In 2001, they released a lot of this stuff, but no one's still sure what happened after the war. Building 26 at National Cash Register Company in Dayton, Ohio, is where all this stuff went on. It was still operating after the war. It's pretty sure that the bombs were being used during the Cold War to crack codes then, and that's specifically why there was such an effort to keep all this stuff classified, because they were, they figured that some of the same codes, the Germans weren't really aware that the Enigma was being read, so it's possible somebody else was using the same encoding techniques after the war. South American countries specifically? Okay. So yeah, South American countries were they actually using it, or was it just, okay. So South American countries were actually using it. So what happened to the bombs? It's not so clear. There are a couple that are in museums, I think 2 or 3. Most of them are probably buried underneath the cement somewhere near Building 26 or in the river nearby. Building 26 actually was destroyed in 2007. The IEEE put up a plaque talking about what happened in 2001 after everything was declassified, and then in 2007 the whole building and everything was leveled to make way for some shopping mall or something, which I don't believe has been built yet. But it's good. They got rid of history, so everything's fine. That's pretty much it. I have a lot of books on this stuff. If anybody wants to come up afterwards, take a look. If I'll be posting some updates on all this stuff onto Twitter, you can follow me. Thank you very much. Thanks. Sorry. Huh?
Sort of see.
Sure.
So I took the time to go to Bletchley Park. Talks about